Hello students, welcome to all of you in this video lectures. Here I am going to continue the chapter probability. In the last class I have discussed about conditional probability. So what is the definition of conditional probability? Conditional probability means probability of an event when one of the event of that particular sample space has already been done. So probability of E over F equal to probability of E intersection F by PF when PF not equal to 0. Similarly, probability of F when E has done, so probability of F by E, probability of E intersection F divided by PE when PE not equal to 0. There are some properties of conditional probability, and these are number one is conditional probability lies between 0 and 1. Probability of E union F by G equal to probability of E by G plus probability of F by G, and probability of complement of event is the 1 minus probability of E by F. Now multiplicative theorem is that probability of E intersection F equal to probability of PE into PF by E. So let us discuss a few questions based on this concept. The question 1 is: a fair die is rolled. Consider an event E equal to 1, 2, 3 and F equal to 2, 3 and G equal to 2, 3, 4, 5. We have to find the probability of P E by F and the probability of P F by E. Second question, probability of P E by G and probability of G by E. Third one, probability of P E union F by G and P U intersection F by G. So let us start with one by one. First question is, when a fair die is rolled, then the number of units in the sample space, that is NS, will be 6, and E is given 1, 3, 5 and F is given 2, 3 and G is given 2, 3, 4, 5. So what is A E intersection F? So what is the common numbers between E and F? 3. So E intersection F equal to 3, and probability of E intersection F equal to 1 by 6, because there are 6 total numbers, so 1 by 6. Probability of PE will be 3 by 6, so 3 by 6 is 1 by 2, and PF will be 2 by 6, which is 1 by 3. Now probability of PE by F, which is equal to PE intersection F by PF, which is 1 by 6 divided by 1 by 3, which is 3 by 6, which is half. Now next question is probability of F by E. So PE intersection F divided by PE equal to 1 by 6. It is 1 by 6. Probability of P intersection F is 1 by 6 and probability of E is 1 by 2. So 2 by 6, which is 1 by 3, is the answer of this question. The next question of this question is here E is given 1, 3, 5, G is given 2, 3, 4, 5 and E intersection G is 3, 5. So probability of E 3 by 6, which is half, probability of G 4 by 6, which is 2 by 3, and probability of E intersection G, which is 2 by 6. Now P E by G equal to P E intersection G by PG, 2 by 6 by 4 by 6. So here 6 cancelled, which is answer is 2 by 4, which is 1 by 2. Now probability of P G by E equal to probability of P E intersection G by PE equal to 2 by 6. Probability of E intersection G is 2 by 6 divided by half. So here the answer is 2 by 3. Third question is E union F. Okay, we have to find E union F first. So here union F is 1, 2, 3, 4 and E intersection F is 3. So E union F intersection G will be 2, 3, 5 and E intersection F intersection G is only one element, 3. Now probability of E union F by G, this can be written as P E union F intersection G by PG which is 3 by 6 by 4 by 6, which is 3 by 4, and probability of E intersection F by G, which is probability of E intersection F intersection G by PG, which is 1 by 6 by 4 by 6, which is 1 by 4. So students, I hope all of you understood this question. Answer. Next question is, given that two numbers appearing on throwing two dice are different, find the probability of the event that the sum of numbers on the dice is 4. So when two dice are tossed, the numbers in the sample space will be 36. And let us take an event of getting the sum of the numbers on the dice is 4. So their outcomes will be only 3, 1, 3, 2, 2, 3, 1. And F be an event of getting two different numbers of two dice. Right? F be an event of getting two different numbers on the two dice. So these are the outcomes for F. Okay, F having the elements other than 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6. So other than these 6 elements, there are 30 elements would be there in the set F. So NF will be 30. Now the probability of that one, probability of E intersection F, there will be two elements 1, 3, 3, 1. So probability of E will be 3 by 36, and probability of F will be 30 by 36, and probability of E intersection F will be 2 by 36. So probability of E by F, probability of E intersection F by PF, which is 2 by 36 divided by 30 by 36, which is 2 by 30. The answer is 1 by 15. So students, next I will discuss about the multiplicative theorem on probability. Okay, so let E and F be two events associated with a sample space S. Then P E intersection F can be written as P E into P F by E. Another one is P F into P E by F. In case of third event, P E intersection F intersection G will be P E into P F by E into P G by E intersection F. So these are called multiplication theorem. Okay. Now when two events are said to be independent events, two events are said to be independent events if P probability of E intersection F is equal to probability of E into probability of F, PE into PF. Now what is total law of probability? Let E1, E2, E3, En be a partition of the sample space S, and all E1, E2, E3, En are non-zero events, and A be any event associated with sample space S, then PA equal to PE1 into PA by E1 plus PE2 into PA by E2 plus PE3 into PA by E3 PEN into PA by En. In summation we can write summation I equal to 1 to n PEI into PA by EI. So this is the rule of total probability. Now let us discuss some questions based on this concept, which are in there in 13.2 exercise. Now the question is, given that events A and B are such that PA equal to 1 by 2, PA union B equal to 3 by 5, PB equal to PB equal to small p, find P if they are mutually exclusive, number 1. Number 2, if they are independent events. So given PA equal to half and PB equal to small p and PA union B equal to 3 by 5. Now we know that when two events are mutually exclusive, then there is no common element between them. So probability of A intersection B will be 0. In that case, probability of A union B will be PA plus PB, right? So putting the values, 3 by 5 equal to PA is half, half plus PB is P. So from this PB is not actually PB is P here. So PB equal to 3 by 5 minus 1 by 2, which is 1 by 10. So P equal to 1 by 10. Now in case of second one, both the events are independent. So for in case of independent events, P A union B, we have PA plus PB minus P A union B, A intersection B. So P A union B is given 3 by 5 equal to PA is given 1 by 2 plus PB is given P minus PA intersection B. From this we can find out the value of PA intersection B, right? Now PA intersection B will be 1 by 2 minus 3 by 5 plus P. So P minus 1 by 10, and the value of P already we have got 1 by 10. So P minus 1 by 10. So it is 1 by 10 is the question number 1. So the value of P A intersection B is P minus 1 by 10. Now when two events are independent, we know that P A intersection B equal to PA into PB. So the value of this, we have got P minus 1 by 10. P minus 1 by 10 equal to 1 by 2 P. So P minus 1 by 2 P equal to 1 by 10. Now after calculation, the value of P we have got the value of P is 1 by 5. So the answer is 1 by 5 for that for independent events. Next question is, one card is drawn at random. One card is drawn at random from a well shuffled deck of 52 cards, in which of the following cases are the events E and F are independent. The first case is E. E event is given, the card drawn is a spade, and F is an event, the card drawn is an ace. So let us check whether these two events are independent or not. So when the card drawn is a spade, so probability of this event will be 13 by 52, which is 1 by 4. Now F is an event, the card drawn is a ace. In that case, PF will be, probability of F will be 4 by 50, because there are 4 aces in the deck of card. So 4 by 52 equal to 1 by 13. Now E intersection F will be 1, because only one ace will be there. So E intersection F will be 1. So probability of E intersection F will be 1 by 52. It is 1 by 52. Now we know that two events are independent if probability of E intersection F equal to probability of E into probability of F. So 1 by 52 equal to 1 by 4 into 1 by 13. So 1 by 52 equal to 1 by 52. Both sides are same. Hence we concluded that E and F are independent events. Second question is, E, the card drawn is black, and F is an event, the card drawn is king. Now when the card drawn is black, what is the probability of this? So when the card drawn is black, the probability of this event will be 26 by 52, which is 1 by 2. And when the card drawn is king, so there are 4 king, so 4 by 52 is 1 by 13. So the intersections of these two events will be 2. Number of units in E intersection F, because there are 2 king black. 2 black kings will be there. So 2. So probability of E intersection F will be 2 by 52, which is 1 by 26. Now let us check whether two events are independent or not. We know that two events are independent when PE intersection F equal to PE into PF. So the value of this is 1 by 26 equal to 1 by 2 into 1 by 13. So 1 by 26 equal to 1 by 26. Hence the given two events are independent events. Third question is, given that E is an event, the card drawn is king or queen, and F is an event, the card drawn is a queen or jack. So when the card drawn is a king or queen, the total probability will be P equal to 4 kings, so 4 by 52, plus queen also 4, so 4 by 52. 4 by 52 plus 4 by 52, it is 8 by 52, 2 by 13. Similarly, for F, PF will be queen, there are 4 queens, 4 by 52, plus jack, also 4 jack, so 4 by 52. So total 8 by 52, 2 by 13. Now, how many common in cards between these two event? 4, because here king or queen, here queen or jack. The queen is common, so 4 queens are there in a deck of cards. So probability of E intersection F, because since N intersection is 4, so probability will be 4 by 52, 1 by 13. Now let us check whether these two events are independent or not. We know that P E intersection F equal to P into PF. So P E intersection F, we have got 1 by 13 equal to 2 by 13 into 2 by 13. Since both sides are not equal, 1 by 13 is not equal to 4 by 169. 1 by 13 is not equal to 4 by 169. Hence, we have concluded that these two events are not independent. So students, I am ending today's lectures. I hope all of you understood, where I have discussed about conditional probability and the problems based on independent events. And if there is any doubt, you can contact me. Thank you very much.